All right, what we'll be looking at in section 2 is talking about our random variables some more. And we're going to do some transforming of them and then also some combining of some different random variables. So in chapter 2, we studied the effects of a linear transformation and how that changed my shape, center, and spread for distribution. So a couple things to remember. If what we do is add or subtract a constant, what it does, it adds that value or subtracts to any location value. So measures the center, so median, mean, our quartiles, our min and max. But it does not change our spread. Okay? So all we're doing is shifting it, up or down. But when we multiply or divide, it changes everything. And it changes my locations. It changes my spread. But again, one thing to remember is by the absolute value, because if, for instance, we multiplied everything by a -2, what would happen is my spread would change by a factor of +2. Okay? Neither one changes the shape of my distribution. So there's an example in the book that talks about this tour company, and they put together a probability distribution where they assume that the number of passengers that they may be able to take is 2 to 6, and the probability of each of those. Okay, so using what we did in the prior section, what I could do now is get my data into the calculator. I got list 1 and list 2, and then again I can go stat, calculate one variable statistics for list 1 and list 2 again. And what that'll do is it'll give me my mean and again my standard deviation. So my mean, or my expected number of passengers here, is 3.75. And my standard deviation for this random variable x is that 1.09. Now, let's say, for instance, that this company wants to figure out their profit. And what they do is they charge $150 per passenger. So now what happens is that this 2, if I get 2 passengers, okay, times that 150 per passenger, that means my profit is going to be $300. Okay. 3 would get to 450 and so on and so forth. So now I want to figure out my new mean. And I'm going to call this random variable C. I want to figure out what's the mean for C, what's my standard deviation for C. I don't want to need to go to my calculator and come in here and do a bunch of transformations, such as what I can do is take my list 1 times 150 to change all those values. And then I can go back and redo this to find my new mean and my new standard deviation. So my new mean, 562.50. And my new standard deviation, 163.46. I want to be able to go back to these types of rules that we had earlier in the year and do the same thing. So what I did, and think about how we did this, what I did was I multiplied each of these x values by 150. So if I do the same thing to my mean, because again, multiplication changes my mean. Oops. 0.75 times 150. There's my 562.5. I'll do the same thing here because I multiplied. I can multiply my standard deviation by that 150. And I get to my 163.5. So rather than having to recalculate my mean and standard deviation for a new table, I can just make those transformations from my original mean and my original standard deviation. Okay, so here again it goes in and talks about the effect of on a random variable when we multiply or divide. Okay. Just like it was with the linear transformation. Okay, if we multiply, It changes my center and location by factor of B. It changes my spread. And again, by the absolute value. Does not change the shape of my distribution. All right, so now let's go and look at what happens in terms of adding and subtracting. So here's my cost situation in terms of this tour situation. Now let's say, you know, we add in that it costs $100. Okay, for this company to get all the supplies and whatnot for their trip. So what we're going to do is we're going to change my table. So even though I make $300 here, after I take away that $100 of my cost, it's going to be down to $200 in terms of profit. 350, 500, 580, 800. Now, I want to come up again with my mean and standard deviation. So again, yes, I could go to the calculator. I could come in here and go in and change this list. And then again, go back into here and recalculate my mean and standard deviation. 462.5. My mean. Standard deviation is 163.46. Now, if we go back again to where we were before, notice that my standard deviation did not change because it was 163.46 before, it still is. But now my 562, if I take away 100, that's where we're getting that 462. So, again, adding, subtracting will change my mean, my location pieces, but not my spread. And that's what this kind of wraps up. So adding the same number, okay, which also could be a negative, okay, adds that value to the center and location, but it does not change, again, your spread. And again, it does not change the shape of your distribution. Those rules haven't changed from earlier in the book. All right, so kind of just a wrap up here. So if I have a linear transformation, okay, y equals a plus bx. X is my random variable. Okay. B is what we're multiplying by. A is what we're adding. So if we did both, not just one at a time, okay, the probability distribution will still have the same shape. What happens again with your mean is both the addition and the multiplication changes it. But with your standard deviation, again, only B. And so for instance, again, you think about Celsius to Fahrenheit, there's a formula there where if I take 5/9 my Fahrenheit temperature and subtract 32, I'll get the Celsius. So the 5/9 would affect both your mean and your standard deviation, but the plus 32 and minus 32, depending on which direction you go, would only affect my mean. All right, sometimes we'll combine random variables. So in this instance, again, we're going to the tour thing again, but we have two different people that run on. We have Pete, who we were using his distribution earlier, and then we also have Aaron's. So now what we want to do is, let's say if we put their company together. Okay, so what's the probability for different situations? What's going to be my mean profit if, you know, we look at both of them for any given day? So what we've talked about is now we got to look at Pete. He's going to be random variable X, and Aaron's going to be random variable Y. One of the possible values that we could come up with is that both of them have 2 passengers on a day. Okay. The next one would be that we could come in and we may have Pete having 2 passengers and Aaron having 3. Pete having 2 passengers, Aaron having 4. Okay. So on and so forth. Then we could jump up to 3 and 2 and keep going. Okay. Now, figure out the probability of these different situations. What we're kind of talking about down here when we look at, say, 3 and 2, what's the probability that my random variable x takes on 3 passengers and my random variable y takes on 2 passengers? Now, if you notice what I have written down here, I have 0.25, which is the probability of 3 passengers for x times the probability of 2 passengers for y, which is 0.3. Now remember, the big rule here for us to be able to multiply again is that we need to have independence. So one of the things that we talked about again was the idea that when you hear the word independent, you have to think about multiplying probabilities or adding variances. So that's going to come out in this section. Okay? So when we look at adding 2 random variables together, okay, what's going to happen with your mean, your expected value is exactly what you would expect. When we transform data, my means do the same thing. So if I transform my data, if I'm going to add 2 random variables together, okay, I can just add those means together. So I can come back here and just simply figure out the mean number of passengers. Okay, let's just add those 2 together. So between the 2, we can expect to have 6.85 passengers on any given day. Now, here's the big one again. Talking about variance. Remember, variance is your standard deviation squared. Okay? Or to get your standard deviation again, we're taking the square root of our variance. That's going to come into play. Now, if I want to combine random variables, okay, and I want to look for my standard deviation, I have to first find my variance. Okay? I can add my variances if I have independent random variables. Okay? Again, key word here. If I don't have independent random variables, I cannot combine them. Okay? And so if I'm asked for my standard deviation, what I would have to do then is to take the square root of that and to come up with my standard deviation. That's one thing that's going to be a little tricky because we're used to just multiplying and doing whatnot when we have standard deviation. Now we have to work with variance. Okay, so if I were to go back here to this situation, okay, what I would have to do to find my standard deviation of the combined random variables, what I have to do is deal with my variance. And so I have to take the variance of x, add to it the variance of y, and go from there. So I would have to come in here and take that 1.09, square it, add to it the 0.943, square it. Okay. So I'm doing that. And we get to 2.077. Now to transform that into my standard deviation, I would need to take the square root of that piece. .44. And that's a tricky thing that you got to be careful. Okay. Now, because we're getting a little short on time with this. If we subtract 2 random variables, expected value means to exactly what we think. But to get my variance, we still are going to combine them. Okay? We still add them because what's happening is our spreads don't change. All right, and then maybe a good thing to do is go in the book this time and look at some of those examples and go through and show you how to deal with combining some of those variables.